Well, for many years we didn't think it was possible. For many years the idea was the oceans are so big they can absorb anything. And we learned in the 60s, the 50s and the 60s, that they don't absorb everything, that pollution gets concentrated in close to continents. We put out pollutants and they don't just disperse equally around the whole oceans. So areas get highly polluted and causing damage to marine life, damage to people. So it's not the case. We used to think that, and we were wrong. Well, in addition to pollution of all kinds, we've destroyed habitats. We've taken important habitats like salt marshes or mangroves and replaced them with seawalls. These are habitats right in the intertidal area, habitats that are crucial to lots of living things, and we've just taken them away and destroyed habitat. And we've also overfished many species for our own consumption. And it's possible to regulate fishing scientifically, and that is beginning to take hold, but there are many species that have been way overfished and continue to be. Well, we need them for fish if we want to eat seafood, not just fish, but shellfish as well. We need oxygen, and a good part of the oxygen that we breathe in the air was produced by tiny phytoplankton in the ocean. We also have many tropical countries that depend on their healthy marine environments for tourism. People come down there to fish, they come down there to snorkel or scuba dive or swim. And if we've wrecked those environments, the economies of those countries will be in very bad shape. Well, there's some chemicals that we've known about and worried about for over 40 years. We can thank Rachel Carson for pointing this out to the general public. And these are kinds of pesticides that were in common use after World War II. Chemicals like DDT is the most famous, but there are dozens of others that are chemically related to DDT. And one reason they were thought to be so good was that they didn't break down in the environment. So a farmer or a homeowner with the lawn or whatever didn't have to spray every couple of weeks, could spray once because the stuff stayed there. Now that seemed like a good thing, but when then you realize that the stuff washes into the water and is destroying and damaging aquatic habitats and environment and killing fish, etc., the fact that it doesn't break down and doesn't go away is no longer a good thing. That turns into a bad thing. So that's one class of chemicals. There are other chemicals that are industrial chemicals that are chemically related to the DDT type pesticides that weren't used as pesticides, but were used for various industrial purposes. And the one famous one there is PCBs that were used in the electric capacitors and stuff transmitting electric power. And there was major pollution from a plant up the Hudson River. General Electric left a big mess of PCBs in the middle 70s. People became aware of that. And then there are, of course, metals from mining, from industrial purposes. They never break down, they're elements. And we have toxic kinds of chemicals, metals like mercury and lead and cadmium that are harmful to not just marine life, but to people as well. And then a whole slew of new ones that, well, not necessarily new ones, they're newly emerging concern about them. They've been around for quite a while, but nobody paid any attention to them before. And some of these are flame retardants, some of them are some of these hand sanitizers in some rooms and bathrooms. You can get a spritz or something. That's got a chemical in it called triclosan, which is really nasty. I mean, it's not going to hurt your skin, you know, but it washes off and it can be, it's got a lot of problems. So we're surrounded in a sea of chemicals. Some of them are, you know, do work in different ways to be harmful, and then some are not that harmful, but we're talking about the ones that are problems. Yes, we have a sick system in terms of approving new chemicals. We have had for, since the middle 70s, a toxic chemical law that was ineffective. And in 2015, Congress finally improved the law. It's still got problems, but they passed and Obama signed a revised toxic chemical law. And they named it after Frank Lautenberg, who was a longtime senator from New Jersey, who pushed this law during his career. But it passed after he died before it ever got passed. But the current administration, I have very little faith is going to do anything under this new improved law. I doubt that the current administration is going to do anything. Absolutely. You've heard about the Exxon Valdez, heard about the BP gusher in the Gulf of Mexico. So certainly the transport of oil and the offshore drilling for oil inevitably has accidents, and there have been oil spills forever, and some of them have been more spectacular than others. They have, you know, we hear about the headlines when something is happening, and there's, you know, the birds get covered with oil and the people bring them in, and the sea otters, and, you know, if it's in Alaska, it's sea otters, if it's elsewhere, it's birds, and try to rehabilitate these animals, and, you know, whales die, and the oil is more on the surface than lower down in a spill from a ship. So it's those animals, the big vertebrates that people relate to, that are killed and injured severely initially. And then frequently, one method of treating an oil spill is to put what's called dispersants on it. And dispersants make this oil that's floating on the top into little pieces, and now it spreads throughout the whole water column. So you don't see a slick on top anymore. And they say, okay, well, we fixed it. Well, the fact is, maybe it's not on the top anymore, but now it's dispersed throughout the water, and it's damaging everything that's living below. And what happened with the Gulf of Mexico, the Deepwater Horizon gusher there, was they dispersed it right at the bottom where it was coming out, so that instead of really going through the whole water column, it sat on the bottom. This whole sludge of oil sat on the bottom and did huge damage to anything that was living in or on or near the bottom. So you can't make it go away. And another thing about oil spills is that if it sinks into sand or mud, it doesn't degrade. If it comes onto rocks with waves battering it, eventually it degrades and it's gone. But when it sinks down below the surface, it ends up in an area with no oxygen, and it just can stay for decades and decades. There was a minor oil spill I think it was 68 or 69, in Falmouth, Massachusetts. Made no newspapers, it was minor. But it happened in a place where there's lots of marine scientists, at Woods Hole. And the people knew the biology of this area before the spill. And so they studied it after. Very seldom is there a case where you knew what was there before and then you can see what's there after. And they documented how many years it took to come back to normal. And in a place like Alaska, it takes much longer because it's colder. And, you know, there are still effects being noticed in the Prince William Sound, where the Exxon Valdez accident was in 1989. They're still seeing effects. It's not killing things, it's not dead bodies, but embryo development of fishes is impaired. They're not reproducing as well. Things like that. So it's very long-lasting, low-level effects after decades, after a spectacular thing. Now, coal, we don't have coal wells. Coal, we don't drill for coal in the ocean, but coal companies are allowed now to spill their waste into streams, and the streams can now go out to the ocean. And when coal is burned, it makes air pollution. And what goes into the air when it rains comes down on land, comes down in the ocean. So we have impacts of both oil and coal in the oceans. It depends what and where and how. The kinds of aquaculture that people are worried about are ones where particularly salmon are grown out in the bays in huge cages. Some aquaculture is on land. You make big, vats and whatever and grow them there, and then you can treat the sewage coming out and it goes into the water. But when you've got the animals out in cages in the real, not the ocean usually it's in a bay area, they're in the cages, there's a whole lot of chemicals that get used to prevent the cages from getting coated with barnacles and seaweed and such. And chemicals, because the fish are more crowded than usual, so there's antibiotics used to try to keep them from getting infectious diseases. There are other kinds of chemicals to prevent them from they get various parasites on the outside, sea lice they call them, and there's chemicals to prevent that. So there's a whole slew of chemicals that then obviously are spreading. They're put in the cages, but the cage has got a mesh like that. So these chemicals are in the water. There's also, depending on the currents, if there's not a strong current in the area, all the wastes from the fish are ending up below the cage on the bottom. So those are the kinds of aquaculture that are causing some problems. Food fed to the salmon or fish in the cages, it's generally smaller fish that are fished out of the ocean in order to feed the farmed fish. The fish that they're feeding them, the smaller fish, would otherwise be the food for some natural predators in the ocean. So it's taking food away. If you grow things like oysters or mussels or clams, this seems to be much less of a problem and much really, in some cases, more beneficial in terms of in areas where there may be too much nutrients and algal blooms. These are filter feeders, and they can eat the algal blooms, and they can improve the water quality. People are doing lots of restoration of shellfish in areas with water quality problems. that, you know, it's sort of a double bonus. You're going to grow the oysters and be able to eat them, and also they're helping clean up the water. So I'm not saying there's never any problems, but these are much, you know, less damaging and in many cases beneficial to the marine environment. These chemicals are not that soluble in the water, but they are particularly, they bind to the sediments, so that though we haven't used these chemicals in decades, they're still there on the bottom, in the sediments, in the mud. And animals can take it up from the sediments and mud. And so we still find, for example, DDT levels in sediments in many areas, and we find DDT levels in the fish and the rest of the animals. The levels are much lower than they were in the 1960s, and they have been slowly going down. But it's slowly because we still have like a repository of these chemicals sitting there on the bottom. Biomagnification is a phenomenon that happens with certain toxic chemicals. It happens with the DDT family of chemicals and the PCBs, which are sort of in the same family. It happens with methyl mercury, which is a certain form of mercury. And what it is that the chemical is in some very low quantity in the water, gets taken up initially into the single-celled plants called the phytoplankton, and then the phytoplankton get eaten by little animals called zooplankton, and the zooplankton will accumulate all the chemical from all the individual phytoplankton that it ate. So it ends up with a higher concentration than the phytoplankton did. And then the zooplankton get eaten by little fish. And the little fish hold on to all the molecules of all the little zooplankton that they eat. So it goes up the food chain that way, so that each level, if we go phytoplankton, zooplankton, little fish, middle-sized fish, big fish, at each level there's greater concentration. And which fish do we eat? We don't eat the plankton, no, we eat the bigger fish. So the ones that we eat tend to be high up on the food chain, and they tend to be ones that will have the highest concentration. And of course, that we're on the top of the food chain, so we're ending up with more than the fish. So some of the fish of concern in this regard, tuna fish and swordfish, and possibly sharks. And not that many people are eating sharks, but tuna fish, there was, you know, I would say don't eat too much tuna fish. I wouldn't say avoid tuna fish, but don't eat tuna fish every day. Particularly pregnant women and little kids. Alternate with peanut butter for the kids, you know, or whatever else. It's those fish that are the ones that are, because being high in the food chain, being big and long-lived. I mean, the bigger you are, the more you eat, and the longer you live, the more you get. Okay, the issue with all the things that you just mentioned is excess nutrients. This is a different thing than toxic chemicals. It's excessive nutrients. It's nitrogen and phosphorus, which are essential nutrients. We need to have nitrogen and phosphorus to live. But too much going in the water will stimulate algal blooms. And that sounds good, right, an algal bloom. But when it gets out of hand, it may discolor the water. You may see the water looks like pea soup. There's a problem there, right? Or it may turn the water different brown or something. These tiny individual cell plankton, out of control growth, can't sustain itself very long, and the cells die. And when they die, they sink to the bottom. And when they're at the bottom, they get decayed by bacteria, and in that process, the bacteria use up the oxygen. So the problem is that you have very low oxygen in the deeper parts of the water. And whatever is living there, if animal life is there, it may be too low for them. If it's uncomfortably low and you're a fish, you can swim away and hope to find a better place. If you're a crab or a clam or something that can either move slowly or not move at all, you're stuck. And you may very well suffocate because there's no inadequate amounts of oxygen. If it's too low but not low enough that you're going to suffocate, you're still impaired, your behavior changes, your physiology slows down, you don't grow very well. So being in low oxygen is a very stressful situation, even if it doesn't get low enough to kill you outright. Okay, I wish I had a chart. I have a great picture of this in my slideshow, but I will do my best gesturing to try to explain this. We have in most cities two kinds of sewer systems. One for collecting the wastes from houses or buildings, from the toilets and sinks and whatever, which is going to go to a sewage treatment plant. There's another kind of sewers, which are the storm sewers, that are collecting excess rainfall. And in many places, this goes directly out into the water without going to the sewage treatment plant. And in that case, it may be carrying bad stuff, you know, coming off streets and whatever. It may have cigarette butts, it may have dog poop, it may have whatever. Used to have more dog poop than they do these days. But, you know, so they thought over 100 years ago, when they built sewer systems in the older cities, including New York, let's send the stuff from the storm sewers into the sewage treatment plant also. So all this street runoff, storm sewer runoff, will get to the sewage treatment plant also. And that made a lot of sense, and that really was a good idea for then. Bear in mind that the population in the cities then, early 1900s, was a very small fraction of what it is now. And the sewage system was built to accommodate that population plus the storms. Fast forward to late 1900s, we now have a situation where when it rains more than just a little bit, there's too much water coming into this combined sewer system, and then it can accommodate. And in order to prevent the sewage from coming back up your toilet or up your sink, they put an outflow pipe so that when there's too much water in the system, out it can go directly into the water body. So then that's called a combined sewer overflow, when you have a combined sewer system. And so that what seemed like a good idea 100 years ago to combine them, now on days when because the population is so much more and the sewage treatment plant is coping with 10 times more sewage waste than it had to, all you need is, you know, more than a little bit of rain. It doesn't take a huge amount of rain, that it now overflows because it's too much water for the sewage system. And so that's when the raw sewage, untreated, is going into the water after rain. Rain is the enemy of water quality in this case. What we need is huge storage systems for stormwater. It's in a lot of people's minds. Many cities don't have the free area to build such a thing. You know, it takes a lot of open space without buildings on it. And, but that's ultimately what has to be done, is to find ways to store stormwater. There are some other things that help, like building more green spaces in the city that will absorb stormwater. They have what they call bioswales. They're putting them into New York. Green roofs, where you know, if the rainwater can percolate down through soil rather than running off concrete pavement, if you had enough more parks and greenery and roofs, and there's also, they've developed something called porous pavement, where instead of running off, they've got an engineered thing with pebbles and whatever, and you can store and then slowly release from like a couple feet below the surface the excess rainwater. So that's what we need, is storage for rainwater. That's what we need. And it's being done little bit by little bit. It's not as glamorous as sending a rocket up into space, obviously, but I think when you add up the problems of water quality from combined sewage plus flooding from storms, the economic costs of the flooding, Sandy, right? Maria, Irma, Harvey, you know, this. You need to find space. Got to take empty lots and make greenery, plug a lot of dirt and grow plants. And this is not only going to look pretty, make gardens, it's going to help absorb stormwater. Will it prevent damage from something like Sandy? Probably not very much. But will it prevent combined sewer overflow from a half-inch to an inch rainfall? Yeah. Well, we talked about the oxygen problem. There are some areas that have extensive oxygen problems perpetually, you know, and that where it's sort of always there, and those are called dead zones. The biggest one around the US is in the Gulf of Mexico. Every summer, a fairly large dead zone forms. They explain how large it is by saying some years it's the size of Massachusetts, and other years when it's worse, it's the size of New Jersey. It hasn't yet been the size of New York, but that's the size we're talking about, of pretty much unlivable chunk of the Gulf of Mexico. Why is that one so much worse than any other? Think about the Gulf of Mexico. The Mississippi is coming in. The Mississippi is draining the whole agricultural part of this country. So we've got the runoff of fertilizers from dozens of states whose rivers and streams are flowing into the Mississippi, and the Mississippi is coming out into the Gulf of Mexico. So with all this fertilizers coming out there, and the years that it's the size of Massachusetts tend to be not so rainy. The years where there's a lot of rainfall, the dead zone grows to the size of New Jersey, because you add rainfall and you get more runoff and more fertilizer, etc. I don't think anybody is doubting this. I mean, we have doubters about climate change, perhaps, but I don't think we have doubters about low oxygen. What a question. Has anybody not seen pictures of beaches covered with debris, right? Debris, trash, garbage, mostly plastic, might I say. This has been a perpetual problem that has been getting worse and worse. It's been getting attention recently. The past couple of years, it's getting more general press attention. Plastic pollution or marine debris is clearly one of the ugliest types of marine pollution. Maybe the oil spill is equally ugly. But it's not only that it's ugly. Plastic pieces can damage marine life in many ways. Things like plastic bags that can float in the water look kind of to a turtle like jellyfish. It's sort of transparent and it's floating along. Sea turtles like to eat jellyfish, and they are not that clear in distinguishing a plastic bag from jellyfish. So there are many sea turtles eat plastic bags. Also, a lot of whales eat plastic bags. And this obviously doesn't provide any nutrition, and it also gets stuck in their digestive system and clogs up things, and a lot of animals end up dying with a stomach full of plastic bags. I have a picture in my presentation of an opened up whale that had a dead whale washed into, and they opened it up, and they saw its stomach was just jam-packed with plastic bags. Animals also get, in addition to eating plastic, they get entangled in it. Whales, seals, birds get tangled in pieces of plastic, particularly ropes of fishing gear. Time was ropes were made out of some kind of fiber, plant fiber. Now these ropes are made of plastic that never degrades, and it can wrap around the tails of a whale, can wrap around legs of seals, it may eventually kill them, it may certainly injure them. So those are two things. Another thing that has recently been shown is that these pieces of plastic in the ocean also act as kind of a magnet for bacteria, for germs. And they did a study that just came out, not in my book, it's brand new stuff. Coral reefs, where there is more plastic debris on them, the corals have much higher levels of disease. Corals get infectious diseases, just like fish or people. And the corals get more infectious disease when there's been more plastic landing on them than areas of coral where the plastic hasn't fallen on them. So that's a partial answer. There's something else I want to talk about here. Plastic can also break up into tiny pieces called microplastic. When it's around long enough, plastic will not break down chemically, but it will break up into little pieces. And these tiny pieces, often microscopic or like a millimeter or so in size, gets eaten by little animals. And you have the same issue with plankton or baby fish eating tiny pieces of plastic. It doesn't give them any nutrition, and it may clog up their digestive tract. Plus the fact that these little pieces not only act as a magnet for germs, bacteria, but chemicals, toxic chemicals will stick onto them. And this may be a way for more toxic chemicals to get into the food chain. So the plastic is an issue that really needs action. And Suffolk County, we're in Suffolk County here. They passed a law, right, for Suffolk County on plastic bags. We did that in New York City, and then the state reversed it. New York City passed a fee for plastic bags, and then the following, and before it ever took effect, the state legislature reversed it. No comment. The thing was, the law that they passed in the state legislature, they said municipalities bigger than X million, which meant New York City. It meant anybody else can have a plastic bag fee or law, except New York City. There's municipalities bigger than 2 million or whatever the number was. Now, why? It's okay for Suffolk County to do it. It's okay. I know before Suffolk County, East Hampton and Southampton had it, and a number of towns upstate. But not New York City can't do it. The point is not that people should pay for bags. The point is they should have their own tote bag and bring it with them. Now, we just decided to do it, and we do it. You know, if occasionally we go to the store coming from somewhere else and we have the bag with us, well, all right, we'll take a paper bag from the store. But if you're setting off from your home to go shopping, there is absolutely no reason not to take your own bag and a cloth or a recycled plastic or whatever tote bag and take it with you to the store and bring it home full of food. When they first started putting in pooper scooper laws, and I said, dog owners are never going to do that. And lo and behold, dog owners are doing it. And the streets are so much better. So people can change. I don't know how much grumbling the dog owners did about the pooper scooper. But, I mean, I see them all doing it now. And it's like part of life. And I think bringing a bag to the store is a lot more fun than scooping up your dog poop, you know? Let me say one more thing about microplastics. We talked about little pieces breaking off and getting smaller and smaller. There are other sources of microplastics in the environment besides breaking up of bigger pieces. There was, and still is in some parts of the world, but no longer here, stuff that were called micro beads, that were tiny spheres, microscopic spheres that were put in personal care products, you know, for smoothing your skin or toothpaste or something, a little abrasive quality. And I mean, people would look under the microscope at samples of microplastics, and some of them that are a perfect sphere, you know, nothing broke down into perfect spheres. And that's what's coming from these personal care products. And there was actually a bill in Congress that banned them. The bill was a couple years ago, and the ban, I think it took effect last year. So any new products you would buy won't have that anymore. By far the most abundant type of microplastic now is something that's not going to be so easy to deal with. They're microfibers, thin fibers, and it comes off our clothing in the washing machine. And it's too tiny to get caught in the filters and the drains of the washing machine. It goes right out to the water, goes into the sewage treatment plant. The sewage treatment plant removes a good deal of it, but leaves one garment in one wash can release 100,000 microfibers. And of course, the worst kind of garments are the fleeces. But anything that's made out of synthetic is going to be releasing tens of thousands every time it's washed. And it's some of it gets trapped in the sewage treatment plant, but enough of it is going out that we've got it by the gazillion in the ocean, fibers. And it's not just floating. Some of the way of sampling is usually looking at the surface of the water. You think it's so tiny it floats, but they don't all float. They found in the deep sea, miles under, little critters with purple microfibers in their stomachs. Unbelievable. I mean, so it's all over, and they're also finding it in the air. So apparently it's coming off in the dryers as well as in the washing machine. It's in the air, it's in the fresh water, it's in the soil. So, I mean, this was originally a marine issue. And now it's real, people are realizing, and there's new papers coming out all the time, it's not just a marine issue, it's fresh water, it's soil, it's air, we're inhaling that. It's in our drinking water, it's in our, talk about health food stores, you buy sea salt. You know, why bother with regular salt? Sea salt is supposed to be real good. It's in sea salt because it's in the ocean. You evaporate the ocean to get the sea salt, and you get plastic microfibers in it. We have no idea what the health effects of all this stuff is. We don't know. And it may be nothing to worry about, but it's all over the place, and maybe we need to learn. These garbage patches, it's not just, I mean, the Great Pacific one is probably the largest, but in all the major oceans of the world, there are current patterns that go round and round. And in the middle there is where stuff accumulates. And so in these garbage patches, in all of the oceans, small floating plastic is accumulating. And it's in areas near them, like Hawaii is not that far, you have much more debris washing into not the developed Hawaiian islands, but there's other Hawaiian islands that are not lived on. They're, you know, going up that way. And they are subject to, you know, winds bringing in far more small floatable plastic than a lot of other places. If you eat a lot of that, I mean, this is not the sort of thing where you eat a meal and you get sick. You know, this is sort of a chronic buildup issue, so that if you eat it regularly, often, for many years, you will probably increase your chances for getting various kinds of chronic diseases, some neurological issues or cancer or something. But it's not the sort of thing with a one-off, you know, you're going to die because you ate a fish out of Newark Bay or something like that. Some people, and they should not do this, flush what they don't use, flush down the toilet. Don't do that. But even if you are disposing of it properly or just leaving it in the pill, you know, in your medicine cabinet forever, when you don't metabolize everything. You're taking some kind of pharmaceutical. It's a chemical that's going to have an effect on you at low doses, and you're not going to metabolize it all. So when you pee, some of that is coming out, and it's going into the sewage treatment plant. The sewage treatment plant is not capable of dealing with it, and it's out in the water system. And some of the kinds of things they find are hormones, like birth control pills, behavioral, you know, neurological things, mood enhancers, antidepressants, those kinds of things. And the fact that these are chemicals that are very effective at low doses means they're in low doses in the water. Fish hormones and fish nervous systems are very much like ours. And you find problems with fish in waters with these pharmaceuticals. So you find, for example, male fish that are making eggs as well as sperm. Now, male fish are not supposed to make eggs, right? You find female fishes that are abnormal, depending on what kind of hormones you had. So you find fish that are sluggish and not behaving normally because there's Prozac in the water. I remember a paper that came out some years ago on this study, and they entitled the paper "Fish on Prozac." That's a cute title. But so that it's affecting behavior, the mood and psychological kinds of drugs are causing behavior changes. The hormonal drugs are causing reproductive issues and changes in the hormones in the fish and the change, so things like that. And not just fish, but other animals as well. Male fish, that you look at a slice through the testes and you see the normal structures that make sperm, and then in the middle of that there's an egg here and an egg there and an egg there. No, it classifies as a abnormality. It's not a mutation, but it's a hormone problem. PBDE is polybrominated diphenyl ethers, which are chemicals that are not all that different from PCBs and DDT. PCBs and DDT are chlorinated, organic chemicals with chlorine in various parts. This is with bromine, polybrominated. Bromine and chlorine are chemically similar to each other. So it would have been nice if people way back, when it was realized that chlorinated chemicals tend to be nasty, thought that maybe brominated chemicals might be nasty, or fluoridated chemicals. Fluorine is in that same. But nobody thought that way. The PBDEs are not pesticides. They're used as flame retardants. And they're put in clothing and put in upholstered furniture. And there was a big movement to do this when there were house fires and the mattress would catch on fire, or the kids' pajamas would catch on fire, things like that. So the idea is to put a flame retardant in the clothing rather than making a cigarette that would extinguish itself. Tobacco companies were behind this move. This is the backstory of PBD, that the tobacco companies were behind, let's put this flame retardant into the upholstered furniture and the clothing, because they didn't want to change the cigarette. That was what set the fire in the first place. Anyway, that's an interesting thing that just came to light much later. But anyway, these chemicals come into the air, go into the water, and they're sort of all over. And now there's some move to do away with them. But they're there, and the kinds of things they do are very reminiscent of some of the things that the pesticides and PCBs did. And they also, the PBDEs also affect the endocrine system, affect the thyroid gland. And the thyroid gland here is involved in development and maturation and the nervous system function. It's involved in metabolism. It's very involved in many things in the body, and something to worry about. When we release carbon dioxide into the atmosphere, and it starts causing climate change, about 1/3 of this carbon dioxide dissolves in the ocean, which means that our climate is not warming up as fast as it might otherwise, because not as much carbon dioxide is in the atmosphere, because about 1/3 or 1/4 of it went into the oceans. So it sounds like a good thing. But now we've got the oceans with getting more and more carbon dioxide in them. And what does that do? The carbon dioxide dissolves in the water, making carbonic acid, and then there's a few other chemical reactions, and the upshot is that it causes the waters to become more acidic. I don't think I want to go into a whole what a pH scale is. No. Let's just say the water is more acidic. Now, why is that a problem? It's a problem because being more acidic, it affects shell formation. And there are many kinds of organisms in the ocean that make shells. There's tiny plankton called forams. There are animals like clams and lobsters, mussels, oysters. And it's in those mollusks where we see some of the biggest problems starting to happen. Initially, a mollusk starts out as a larva for a baby. You know, they mate, and you've got the embryos in the water. The embryo turns into a larva. The larva, tiny, in order to make it, has to find its way to the bottom to settle and make a shell. That's the critical stage, is making that shell. And the water is too acidic, it can't make the shell well or enough or whatever. And these were problems that actually seen in the West Coast, in Oregon, in an aquaculture, a shellfish aquaculture facility. And they had a failure of the larvae to metamorphose is the word. This was like 10 years ago or more. And they got scientists involved to see what was happening. And it turned out that the water, they were pumping up water from deeper down, was more too acidic. And so now they can add alkali, to change it in the aquaculture facility. So they can fix it, but that fixes it for what they're growing. It doesn't fix it for the clams out in the wild. So it's making a shell is one of the major issues in ocean acidification. There are many other effects, including effects on behavior in fishes as well as in many other animals, particularly behavior that depends on the sense of smell. Many animals in the ocean, fishes and crabs and lobsters, sense of smell is really important. Think like a dog, animal we're more familiar with. Sense of smell is very keen and very important. And it's used by many fishes for navigation, homing, salmon going back to where they came, where they were hatched upstream. They live in the ocean, they got to go back. They go back to the very same place. Acidification in the water impedes their sense of smell. A sense of smell is also important for predators detecting their prey. I said, this is or for prey detecting their predator, and they can smell either the predator or they smell an injured member of their own species, and that tells them, I gotta hide, I gotta get out of here. And that's impaired also by acidification. So that predators can be impaired in their ability to catch the food. The prey can be impaired in picking up the fact that there's danger here and I got to hide or go away. And reproductive behavior also is very often dependent on sense of smell. So ocean acidification is impairing these kinds of things. There's a whole lot more attention being paid to the shell formation problem. But I think in the long run, the behavior problems, because of impairing the sense of smell, will end up being more important because it's affecting not only shell-forming animals, but it's affecting a much larger bunch of different animals. Oh, yes, absolutely. The bleaching of the coral reef is due to temperature increases. It's global warming. The speaker earlier mentioned that over 90% of the heat is going into the ocean, the heat from climate change. Over 90% goes into the oceans, which means here on land we're not warming up as much as we otherwise would. But, you know, from the standpoint of the things that live in the ocean, it's warming up much faster. And there are thermal limits to what any animal species or population can tolerate. And what happens to corals are the canaries in the coal mine here. Corals, many species are very sensitive to temperature. And when the temperature gets too high, let me back up a little bit. Coral animals are tiny little things that look like sea anemones, and they secrete a shell, calcium carbonate. So you see what's called coral, it's just a skeleton, right? But inside all the little holes in that skeleton are individual little animals. These individual little animals have inside themselves single one-cell algae plants that photosynthesize and give most of the nutrition to these little coral animals. These little coral animals also have tentacles. That's why I'm wiggling my fingers around. They have tentacles and they can catch food also. So they get food from two sources. One is catching food, and one is the photosynthesis of these little algae inside them. When it gets too hot, the little algae leave. So the animal is dependent on its own food catching. Some species can catch enough on their own to survive, but many coral species really need those algae to make the food for them by photosynthesis, and cannot do it well enough on their own. Those are the ones that are going to die. Now, so bleaching means those algae have gone. So the coral looks pale white, just like, you know, a piece of coral skeleton. A normally living coral has a brownish or bluish or, you know, has a color to it. It's not pale white. Bleached algae is pale white. Bleached does not mean dead right away. If the temperature goes down enough, algae can come back and they can survive. But if it stays too hot for too long, it's dead. And that's what happened last year and the year before at the Great Barrier Reef in Australia. And huge areas of the Great Barrier Reef died because it stayed too hot for too long. And why does that matter? The living reef supports fishes and lobsters and a whole host of other marine life. The coral reef is one of the most diverse and productive kinds of ecosystems on the planet. And it also supports the economy, as I said earlier, in many parts of the world for fishing, for scuba diving, for snorkeling, for boating, for whatever. And if it were a beautiful forest that were chopped down, people would relate to it right away. The problem is it's under the water, and most people have never seen it. But there is a wonderful movie. I want to make a plug. I had nothing to do with this movie, but it's called Chasing Coral. And it's about a team of filmmakers and scientists who went and were able to film the event of the bleaching. And, you know, it's a movie, you should bring some tissues. You don't usually cry over the death of a coral, but it's a beautifully made movie and really tragic. Well, sea levels are rising. One thing is that when water is warmer, it expands. That's a basic principle of physics. So the level goes up because water is warming. It's also getting warmer because of melting glaciers, and melting ice on land runs down into the water. So you're getting more water coming in where there hadn't been water before. So those are the two things that are causing sea levels to rise. Why should we worry about it? We have lots of cities and towns around the world that are right on the coast. And we are already seeing places like Miami Beach, underwater, even on sunny days. It's not a matter of storms and flooding. It's some sunny days when the tide is high, it's on the streets. And it's true many other places. There are small island countries that are making their plans to move elsewhere because their country, low-lying, small islands, Kiribati, Tuvalu, some in the Pacific Islands, they are planning, they're going to be leaving their homeland because their homeland is going to be underwater. A higher sea level means that when you get a hurricane, it's starting out higher. So the storm surge is going to be that much worse, and the damage is going to be that much worse because your starting point is higher to begin with. And it's not just that. It's the natural habitats at the edge of the water. Salt marshes. Salt marshes are an amazing group of plants and associated animals that live part-time underwater when it's high tide and part-time in the air when it's low tide. And they are living in a certain range. When you get, as the water goes up, what can a marsh do? A marsh either has to rise up to keep up or move inland. And in order to rise up, you've got to be able to collect enough sediments to increase the level. And some can and some are not getting enough sediments. And then the alternative is moving inland. But if you're certain places, you're going to run into a street or a pavement or a town, and there's nowhere to go. So someone coined the term coastal squeeze for what's happening to salt marshes as the sea level rises. Now, why should we care about salt marshes? Salt marshes are protecting us. They are a buffer against storms and winds for people living inland of the salt marshes. Would a healthy salt marsh have protected Lower Manhattan from Sandy? No. But it will protect to some degree from some storms. And it also is very productive. And if you like bird watching, that's where birds are. Salt marshes are also nurseries for many important fish. So the baby fish are living there, and then they go into deeper water later. It's a very important community, both for the marine environment and people, and they're at great risk for sea level rise. So not just damaging houses, although that certainly resonates with more people than salt marshes, but the salt marshes resonates with me.